I'll get started?
Sure.
Sure. Hey everybody, thank you for coming to listen to Sean and I talk a little bit about our experiences with OpenShift, with virtual machines, with a lot of OpenShifts. We've got a large-scale deployment, 150 or so locations. We thought it'd be a good idea to propose to the summit organizers that we talk about some of our experiences, and regretfully they agreed, so here we are now, right? But wanted to say hello and introduce ourselves. Maybe I'll let Sean go first, and then after you,
Yeah, since I have so many titles here. My name is Sean. I'm the Chief Systems Engineer with Raytheon Technologies. I'm on a contract with the National Weather Service under NOAA on their Advanced Weather Interactive Processing Systems platform, shortened to Awips.
That's right. And my name is John Call. We like to keep our names just monosyllabic, so Sean Webb and John Call. Very short and easy to remember. I've been with Red Hat for a number of years, and it's my privilege at the moment to be an OpenShift resource that gets to engage with our customers while they develop their pilots and their proof of concept and their demos. And I support the government customers, so NOAA is in my bailiwick. All right.
So a little bit more about Awips. This is the platform. We're encompassing hardware, network, as well as the software that runs as part of Awips. And this system is used to collect weather data, issue watches, warnings, advisories, and the official products that you can get from weather.gov, all from this platform. So it's used to ingest that data. There's a lot of data out there: model data, satellite data, radar data. This is pulling all that data in, processing it so they can display it, manipulate it, and then, like I said, ultimately it's used to create forecasts and those warnings that you guys will get to your phones and to media, et cetera. So,
as an interruption, has anybody set up their alerts for the weather alerts, or does that just come naturally?
Yeah, I think you'd have to turn it off on your phone, really. I don't know about like the EAS alerts that a tornado is coming and batten down the hatches. So this is just a representation, as John mentioned in the intro. There are over 150 disparate locations where they're doing this work. Their current sort of operating model is that they staff forecasters at each of these red dot locations, and it's usually co-located with a radar system, right? So they're managing a radar dish at that location as well, ingesting that radar locally, and then they actually send out that radar to the broad network so that everyone can get those radar products. But more importantly, they're getting those local radar data to do forecasting for that region, for that little area. So each of these dots, each of these locations have an Awips system, and like I said, that's a collection of hardware, workstations, some auxiliary devices, all towards really pulling that data in and processing it and so forth. And then there's also other types. So that we primarily talk about weather forecast offices. They're doing those alerts and things. River forecast centers have a slightly larger area, so there's 13 of them, sort of centered around river basins like Upper Mississippi and Lower Mississippi, and they're doing more long fused river products. And then we have a lot of test systems, and we have a couple central management systems that we use to help manage all these instances. It's called the Network Control Facility. That's where we run like satellite, for example. That's where we have our satellite system that we then push patches out through capsules installed throughout this network. And here's a little example of one of the applications that they actually run. And this is to actually produce the text of a severe thunderstorm warning that you would see. So they're allowed to, you would normally see some radar data in here, and they would highlight the area that they want to warn for. And this is a templating language that's used to generate automatically populate this with data, so they're not having to type a lot of things. You don't want to have to type a lot of things when you're about to issue a warning, right? So a lot of stuff is pre-filled in based on some selectors that they have. So. Here, I'll let you drive. I don't remember what animation you put in.
No, I tried to interrupt and you wouldn't have it, so.
Yeah.
I wanted to go back for just maybe a half a moment and talk about, so in addition to the hardware, I'm a nerd and I love servers and blinking lights, but all of these red dots have people like this gentleman here, right, and screens. Could you maybe talk about the screens and the people?
Yep. So each workstation has a multi-headed display so that they can actually have that application up and running and displaying certain pieces of data across that interface. So, it's hard to tell, but the guy's got like a radar product on the left and multiple radar. He's actually got radar products across the board. He's actually looking at different pieces of information from that radar, probably doing, some analysis of, wind speed coming from that storm, rotation, if there's any tornadoes, things like that, looking at multiple levels. If you guys know anything about radar data, they actually do a scan, and each scan they tilt the radar so that you're getting you want a, not quite 3D, but you want a good column view of that storm. So.
Yeah, thank you, Sean. And one of the things that fascinates me as a taxpayer, I'm grateful for the service that these folks are providing in analyzing the situation and alerting me in advance of what's going to be happening. In the event that there's some kind of a hiccup, like I'm in the Salt Lake City area, so I appreciate the dot on Salt Lake City. In the event that something happened at that location, nearby regions can help out, or we could even send staff to nearby regions to then forecast on the.
Yeah, that's correct. There's the data that's being collected at each of these sites is all the data for the U.S. So everybody's seeing the same data, but like you said, that if a node did go down, if one of these sites did go down, then a neighboring site will pick up their operations, maybe staff up either locally or with people from the other office, depending on how long that outage was going to last. Yeah.
Thank you, Sean. And then as far as sending out the alerts, this black screen here is a projection of the greater Massachusetts area. And then the bounding box, depending on how much of that box touches a given county, will determine if that alert goes to that county, or if not quite enough of that county will be impacted, then we can not wake those people up in the middle of the night. Right. So let me talk about the stuff that I love to talk about, which is hardware and blinking lights a little bit. In all of these, give or take 150 or 200 locations, there is at least a triple of servers. So we might say, cute things like 150 data centers, but it may not be the same data center in all situations. Other sites have much more hardware, but in this distributed nature, the current infrastructure is that we're running virtual machines on top of a hypervisor in a hyper-converged fashion. So we take individual hard drives that may be in each of the servers, and we combine them together with the power of Red Hat technology in a product known as Gluster. And then on top of that aggregated storage, we run the virtual machines where all of the data is received and the analysis takes place. Could I ask you, Sean, maybe to talk a little bit about some of these virtual machines we put on the screen? How many VMs does it take to run the Salt Lake or some other location?
Yeah, and let me take 30 seconds to say, we used to have 12, 14 at least physical machines at each of these offices, and as part of sort of our first phase of some migration efforts, we at least got them to virtualization. But because of time and money, all we did was we virtualized each of the physical machines into a virtual machine. So we didn't get a lot of cost savings, a lot of improvement in our software. So each VM really just represented a physical machine that we already had running in that environment. So we were able to go from, like I said, 12 to 14 at least physical machines and take that down to this 3-node system that we have now. So we've got, for example, a VM that runs Postgres database. We have a couple that ingest the data, so take that raw data and actually translate it into a product that we can display on those monitors, right? We're using a system called Cupid to help everything communicate with each other. So lots of little components like that all have their own VM. We have an NFS VM to share out certain volumes that have to actually be present on all the VMs plus the workstations. So.
Nice, thank you, Sean. So all of this is fantastic and interesting, but you didn't come here to learn about yesterday's architecture and infrastructure. You came to learn about tomorrow's architecture and infrastructure, right? So hopefully we'll say the word container at some point in this presentation. But the legacy of Awips is 20 years, 30 years?
Yeah.
The Awips program has been going on for a long time, and it's difficult to take an institution of that size and that tenure and quickly pivot it to something else. So what we're talking about today is how we're beginning to move that infrastructure to something else. And what is the genesis of all of this? Why do we have to make a decision now? Well, unfortunately, some of the products that are in use right now, like the hypervisor and the distributed storage aggregation, the Gluster FS, some of the combinations and permutations of that software will no longer be supported in about 12 months. So we better get our butts in gear and we better get going so that we don't find ourselves in an unsupported situation. The government and our security girl, she does not like unsupported, does she?
How long was the current environment? Like, when did it get started?
How long was the current environment? When did it get started?
The virtualized environment. We probably did finish deployment 2 years ago, I think. Almost 2 years ago.
And when did it start? It's like
4 years ago. Yeah. We had, I think 2018, because you were involved in that, I think that was about when we started prototyping and then building out that VM system. I think it took 2-3 years to get that out. So I think it was 2021 when we finally had it deployed at all offices. And now we're starting that journey again. And we're going to do it in less time and with less resources.
That's right.
Yep.
That's what the boss told us we were going to do.
Yep.
So this hilarious picture that I found on the internet is an actual picture, aside from the cartoon dog in the corner, but there's this gentleman in Canada who thought it would be a good idea to cut his grass with a tornado spinning in the background. Yeah, if you Google like odd Canadian tornado, I'm sure you'll find it. So in addition to the end of support, it would be great if the Weather Service would just throw a bunch of money and time at this project to get it done, but that's just not in the cards right now. So we need to do something different given the constraints that we already face, which is we can't increase our budget significantly to do something radical. We just need to do more with less. And for now, a virtual machine-based infrastructure is good enough, but what about tomorrow? And the developers are on your back. I heard that Python is a big deal for you, right?
Mm-hmm. Yeah, Python is huge in the Weather Service community. You know, they do a lot of local development, and it's primarily all Python. So.
Yep. So from the high level, pressures that are bearing down on us, let's take a sideways step and talk about some of the technical pressures, right? Because we need to maintain the existing feature set that we're providing to the citizens of the United States. And some of the technical hurdles are that there's 150 sites, and making sure that all of them operate and report their failures and report their successes and report their resource consumption is important. That's really difficult to do right now given the infrastructure that's in place. Just making routine security patches and updates is difficult because, believe it or not, there's some RS-232 serial, we're talking old school communication protocols that connect the Weather Service's infrastructure to your partners like the
FAA, yeah, and some emergency responders, for sure, yeah.
Yep. And sometimes, just because of the nature of some of these sites being very far away, the connection between them would hiccup, and that can result in a corruption of the hypervisor, and then when you have to rebuild a hypervisor, it becomes challenging. And there's our blessed security thing that scans the hypervisors, and then something breaks. And is that the scanner's fault, or is that the hypervisor's fault? We haven't figured that out, but there's no time to figure that out. We need to continue to be operational. So where is our savior? I talked about turning into Clark Kent and Superman just a moment ago. We need something to swoop in and save the day. And as we've been conducting our research and looking for options and alternatives, we landed on OpenShift, particularly because OpenShift allows us a platform to lead into this container-based and microservice world. But OpenShift a couple of years ago also gained the ability to do legacy stuff. I don't know if you want to jump in and say anything, or I'll keep talking. So OpenShift has been around for a long time. Kubernetes was announced downstairs as being around for almost 10 years now. And if you're not familiar, OpenShift is a distribution of Kubernetes, right? So if OpenShift is a distribution of Kubernetes and it can run pods and it can run containers and it can handle microservices and so on and so forth, then what was the impetus to run virtual machines? Red Hat acknowledges that not every workload can easily be translated into a microservice today or even tomorrow. Some applications and some services will likely remain as a virtual machine until the end of their life. And Red Hat wanted to guarantee that those workloads, those virtual machine-based workloads, could continue to run in OpenShift. So as a stable feature and as an alpha and a beta experiment even preceding this, as a stable feature, OpenShift gained the ability to run virtual machines a few years ago. It's using the same technology that the hyperscalers, hyperscaler is a cute word to refer to Amazon Web Services and Google Compute Platform and so on and so forth. But the virtualization technology that's built into OpenShift is the same virtualization technology that Red Hat has been using for a long time in our other products. And it's the same KVM technology that Amazon and Google have been using for a long time in their data centers. What's a little bit different is that the virtual machines are native first-class citizens of OpenShift. So they are treated just like any other object or manifest inside of OpenShift. They're scheduled, they're created, they're destroyed. They're guaranteed to be available just like any other Kubernetes-based resource. So they are first-class citizens. Along with that, there's a bit of a diagram showing the connection points between virtual machines and container-based microservices. As the bullet points would illustrate, the virtual machines, because they're first-class citizens, they plug into the same network or networks if you have multiple of them in your cluster and take advantage of all of that as well, and storage subsystems. And we'll have some time at the end here as well to ask questions and provide answers, and grateful for interrupting us as we go as well. But let's talk about some of the other benefits that we get from OpenShift. On the last slide, we talked about how the support window is closing for the current infrastructure. OpenShift has a bright and long future ahead of it, and with Red Hat support, we're able to remain on a known version of the product for as many as 24 months. OpenShift is a distribution of Kubernetes, which is 100% certified Kubernetes by the Cloud Data Computing Foundation. But the other benefits that are more tangential and address some of the technical challenges we talked about are the one-click updates. And you've seen this in the testing environments you've already deployed, right? The ability to one-click update?
Yeah, right. It's so far, it's been a lot easier than the previous Red Hat virtualization software. And mostly, I just love that it's image-based, and as part of our requirements with the weather service, we had to hack into the virtualization hosts, to satisfy some security requirements and other requirements. I like now telling them that no, you're not allowed. You're not allowed into the node. It's an image-based. We're going to do some configuration via machine configs, and that's going to keep our nodes stable and at the configuration level we want to be, and that's it. We'll have other mechanisms, which I think we'll get into later, of making sure that those are secure and making sure that those are compliant and correct, but not by you SSHing into it. We've caused ourselves some problems with the previous patching and update procedures by going in and manually applying STIGs and adding the ability for scanners to come in and do credential scans and things like that. So I'm looking forward to telling them no.
Yeah, I think we've got better tools is the kind of takeaway. I want to focus a moment just on some of the diagram here, which is we have documents, we have YAML files effectively. I just wanted to say a cute word like documents or manifests, right? But we have text-based inputs that go into the hub cluster, and from there we distribute the configuration to all of the clusters, right? So some of the things that we saw in the previous slide about defining the storage in a hyperconverged environment, we can define that in YAML and then apply it to the hub cluster. And if we want to be selective, we can use label-based selectors and say that this configuration goes to these clusters and that configuration goes to the other clusters. But the idea is that everything gets described as a YAML manifest and is fed into the system, not only for the initial setup and the configuration, but for the ongoing compliance, if you will, to make sure that the state is in the state that we intended and hasn't deviated or drifted from what we intended. Okay, so let's take a look at the new proposed Awips architecture. And spoiler alert, the new proposed, at least hardware architecture is exactly the same as the infrastructure that's running right now because the hardware is sufficient. The model servers, Dell, that we have are adequately resourced. The virtual machines are doing their job, but we are gaining the benefits of OpenShift and this new cloud-native operating system, this cloud-native platform, if you will, to do things different and better now. We have better manageability because of the manifests flowing into the hub and the hub pushing them out to the remote sites. And we have the ability now, because it's a Kubernetes-based platform, for the developers to begin to innovate, build their own container images, put whatever version of Python that they want into that container image, and co-schedule the new with the legacy. Anything else on that, Sean?
No, but go back for 1 second. I mean, actually go back one more.
Sure.
The central operations managed security, again, that's a huge plus for us. Like we were just talking about. The previous solution didn't have that ability. We deployed over 150 RAI clusters out into the wild, and we had to physically log into every one of them to see, or write tools or write Ansible or what have you to make sure that those were all operating correctly. We didn't have a centralized solution unless we came up with something on our own. So the fact that starting with OpenShift, we're getting some of these things out of the box is great. Again, going back to the, time and budget.
I missed my opportunity to have my big reveal as well and do multiplication facts and show my math expertise on stage. 150 locations, let's round it up to 200, and each site has a minimum of 3 servers. Some sites have as many as 6 or more servers. The scale is we're looking at 600 plus nodes and 150 plus sites, and it's a lot to wrap your head around. So Raytheon is in support of NOAA, and Sean is doing good work for the citizens. So where do we go from here? We talked about the platform then being able to handle the legacy virtual machines and co-schedule the new stuff, right? So what's next for NOAA and Awips?
Yeah, I mean, past this work, we're going to, they're already looking at going to the cloud. They already have some work started to take a lot of what you see on the right and try to, right now these are giant Java JVMs. For the most part. So they're looking at splitting that up into microservices, the same cloud stuff that you guys are hearing about all the time, and trying to, decouple this stuff and get it out into a format where we can containerize, and we can start, being able to, spin up and spin down services depending on load and things like that. We don't have that ability right now. So that is what's next, and that's that's a big thing. But there's some challenges ahead, as we get down to how to handle client interactions with the cloud data. So, we expect that the model that they're going to go to the future will be having all this data and all these services in the cloud. No longer at these physical data centers. So, but will they still have people staffed at these locations with these graphical workstations there and doing their work there? Probably. I don't know that they're going to be able to get away from that. So how are those? How are we going to have them access that data? And what sort of issues might we have with latency, right? Because you need that data quickly. So how do we streamline how they get all that data to actually visualize? On those clients. So.
Yeah, and the last 2 bullet points that I would mention is that, our approach at NOAA is a little bit different than many other approaches, which is to, NOAA will remain in control of their own destiny and install and manage their own software, self-install OpenShift, but many others are saying, I'd like to push the installation, management, patching cycles to some other managed service provider, and those options are available as well in the cloud. So with our partners at Microsoft with Azure, there's a technology known as Azure's Red Hat OpenShift, where from the Microsoft Azure catalog, you can check out a cluster. It's managed and maintained by a cohort of both Microsoft and Red Hat site reliability engineers, and all the customers are expected to do is manage and maintain their own applications and their own code. And the same is true for AWS as well. With Amazon Web Services, we came up with a different clever acronym called ROSA, if you hear that. Red Hat's OpenShift on AWS. Again, co-managed between the site reliability engineers of AWS and Red Hat together for the benefit of just giving customers the ability to do their own code and not worry about the infrastructure below it. That's the high-level presentation that we came prepared with today, and we're happy to take questions and answers, but extremely grateful to NOAA for sticking with Red Hat as a partner and being able to embark on this OpenShift journey of carrying forward the legacy while we plan for the future and understand the constraints given the hardware and budgets we have today.
Yeah, for sure. And John, you know, as a solutions architect, has been huge in getting us started. You know, we started prototyping OpenShift on our hardware 6 months ago, 7 months ago. And, you know, we're now in the position where we're actually starting to deploy in our test environments and figuring out how to best automate. Because as we said earlier, we're under a tight deadline to get all this deployed by basically end of summer 2024. This is actually a combined effort for us because we also are using RHEL 7, and RHEL 7 end of life is end of summer of next year. So we started that knowing that RHEL 7 was end of life. Now we know that the RAI infrastructure, all those components sort of end October, I believe. So we're trying to get both of these now done within the next year, just over a year. So we're on a really tight deadline, and like I said earlier, so far in all my work with OpenShift, you know, the interfaces are a lot easier than we had to deal with before, can better visualize sort of the way we're going to be able to automate this and get this deployed 150 plus times. So I'm so far really pleasantly surprised with OpenShift and the tools and how to use it. So yeah, so it's been a good experience.
So there was a question here in the front and then here and here.
Is there a plan to take the, you said with OpenShift, it's hosted the VMs, is there a plan to move those into containers and microservices, or like you said, some of them may not ever do that just because they're old and legacy?
That is the roadmap. So if you ever, and I don't know if their roadmap is cloud by the end of this decade, I believe. Okay, so they currently are doing that containerization, that taking of this code base and trying to make it work inside containers and things like that. You know, as I'm sure, I think John mentioned that really from a virtualization standpoint, it is a container, it is a pod. It's just wrapping a whole VM in there instead of, you know, a small, lightweight, you know, container that you might be used to. So, so yes, for right now we just don't have the time to do that work now, and I don't think they're going to give us the leash to really do that until they start working in the cloud. Yeah, the code itself will be the foundation, the whole VM structure. I mean, if they gave us a leash, there's some certain things that we could have, you know, like Postgres, having a whole VM for Postgres. You know, what did we? But again, just time and money and budget. And,
yeah.
I wonder if there's any limitations or lessons learned, things that you guys encountered. I saw the note about the large VMs. I'm curious what that meant. But are there any other things that you encountered that you would refer someone to?
So far with OpenShift, no, and you know, with the old solution, you know, we've been looking at those and seeing what hasn't worked. You know, for example, patching. Patching right now, just the infrastructure, in some cases brings the VMs down, either because it had an issue or because we had certain things that required high availability and that platform didn't handle it very well. So, you know, the weather service, this functionality, this is all about 24/7. And that's what we're looking at now with OpenShift, is just seeing how these components that have to be up, stay up and don't cause these outages. Haven't quite gotten to there with our testing and verification of this stuff, but we're hopeful so far with what we know about it that it will work better, and that the downtime will be less. With the node update, seems like it'll happen quicker. But yeah, there are certain things that tied us to certain nodes simply because of resources or like that communication channel. And what we're going to work on is try to make sure that it can fail over to another node and not cause impact, because we didn't think about that with the original architecture. I don't know if you think of it. I can't remember any other challenges that we're trying to solve with OpenShift.
Yeah, you were talking about the overhead of the large virtual machines. So like the Postgres database has this many CPUs and this much RAM.
Exactly. We're allocating a 24 CPU virtual machine with 36 gig of memory, just to run Postgres.
You're not talking about a challenge within OpenShift virtualization. You're talking about
A challenge on the program with how we are using the product, yeah.
Yeah, I'll come to a question here and then maybe follow up on that.
Yeah. So how do you plan to deploy or automate the deployment of OpenShift on Red Hat on 150 sites?
If I could just restate the question, you're asking how do we plan to automate the bare metal deployment of 150 clusters? Very carefully. Yeah, there's actually a different slide that we presented yesterday, and I'd be happy to bring that up, but maybe you want to do that while I'm bringing up a different set of slides?
Yeah, going back to those tools, so ACM, ACS, Advanced Cluster Management, Advanced Cluster Security. Advanced Cluster Management, one of the things about our environment is that we are, we're not on the internet. We're firewalled at network levels that don't let us get out to the community, except for when we ask for specific rules and things like that. So with we're going to set up some centralized clusters. Like I said, we'll have a test one and an operations one, or maybe two operational one. And from there, we will use those tools to help us deploy the 150 clusters, maintain them, monitor them, and use, like I said, use OpenShift to manage the clusters. And we've been, John and I, whenever we talk, we're banding about ways to do that. We can very quickly, and this is again just from my previous experience with my current experience with OpenShift, is that I can get a cluster deployed in under an hour. And it took 4 hours to do it with. It took half a day for us to get to the point where we could start deploying things on Rye. So already we're seeing the benefits of how quickly we can get this stuff done. And that's even with me clicking buttons. So there's certainly going to be some opportunities to use ACM, use Ansible, use some other tools to let us run this from start to finish and get OpenShift to get that cluster deployed, and then we have to deploy. It's called OCP Virt, OpenShift Virt. So we have to install. Well, before we do that, we have to configure the storage. So we've got local storage. So it's just going down that path of 4 tasks, and hopefully coming up with a way to do that even more automated, so that we can actually do it quicker than we did the original deployment. Because I think I was answering your question before, that it took us a year, I think, to fully deploy Rye, and we're probably looking at 6 months for this. And I'm confident we can do it. And we haven't pieced together that flow yet. But like I said, I can do it manually, in half a day, the whole thing. So
does that help? Would it help to maybe walk through this in about 60 seconds? Is that okay? So from a practical perspective, the 600 bare metal virtual machines are down here, right? And there's an engine, there's a workflow, there's a process, if you will, that comes with another set of software called Red Hat's Advanced Cluster Manager, and it's known as the zero-touch provisioning. So this Advanced Cluster Manager has the ability to create other clusters. And in a cloud environment like Google or Azure, et cetera, it's very simple. You just give them enough credentials into your cloud environment, and it will create instances, and it will create networks, and it will create the things that it needs to create. Now with bare metal, it's a little bit different, right? So, but there's this thing called host inventory, and that's the key. It's this one in the corner over here. Sorry, I could have done a better job getting a better picture. But the idea is very simple. We just need to create a YAML file that provides the IP address of in the case we're using Dell servers, so the iDRAC, the interface, and the credentials to log into that. And with that information, Advanced Cluster Manager is able to log in to the servers to boot them.
Attach them to an ISO that has the software on it.
And
It's a kind of remote boot.
Exactly, yeah.
yep, exactly.
So we're remote booting them through this interface to get them to boot into a live core OS, that has now the information about, you're going to be a cluster. It starts communicating back to ACM. Once it sees all 3 nodes are online, it continues, and it'll
Yep.
build that cluster.
So yeah, let's go here and here.
Yeah, quick follow-up to this, because how siloed are all these locations? You're gonna gain with this, obviously, workload resiliency, but from a location
Yeah.
resiliency aspect, just
They're
how wired in is it?
they're very siloed. Yeah.
There's no real ability to shift anything?
No,
like-
no.
Like an in-between point between multiple locations?
Correct. Yeah. No, we don't. Yeah. And that's just simply their operating procedures from 20 years ago just haven't caught up with the technology. So they have software in place that shares configurations that are central to their forecasting. So in the event that one site goes down, they're just pulling that, they just have a copy of that data, and they can locally spin up, another thread that is going to let them forecast for that site. There's no, there's no sharing of resources in between the systems real time or anything like that. So.
Do they foresee any benefit that with this kind of in-between step and maybe continuation of some stuff, that then you would gain the ability to go outside that cluster in some way?
Yeah, we'd have to research that and sort of give them a plan. I mean, I see benefits to that, and we have for years, but I don't think anything's really going to improve until they get to the cloud and they completely sort of peel back and rebuild. At one point, I know he had a slide up, and each of these sites are actually configured slightly differently, and that's a challenge from our software perspective, not from the infrastructure perspective, but that's going to be a challenge when they go to the cloud, because each forecaster is expecting a slightly different view, or they want their data to be formatted a separate way or displayed they have a lot of customizations even from a software level that is going to make going to the cloud a challenge, because now how do you differentiate what each region does things a little differently, so they can have regional configurations that they can somehow pull down and use from the cloud. That's going to be a challenge. So did you have something?
I think that we got about
5 minutes?
7 minutes, so maybe we can take 2 more questions and then move, and then you happy to move to the hallway track, Sean?
Yep.
And we'll ask some more
Yeah, we'll be
questions
around.
outside. Okay.
Sounds good. I've installed Linux-based workload. Can you run non-Linux-based, for example, Windows VMs on this platform?
Yeah, that's a great question. The question was, are all of the virtual machines and all of the systems running on Linux, or could they run on a Windows or something else, right? Presently, they do all run on Linux, but the virtualization technology is supportive of all of the currently supported Windows operating systems, Windows 10, Windows 11, Windows Server this, Windows Server that. I hesitate to say which Windows Server 2012 because I don't know all of them and I'll look silly on stage, and I don't want to look silly on stage.
Yeah, if you install OCP Virt somewhere, it comes with some pre-done images of Windows, Red Hat, CentOS, so
Yeah.
you can install anything on top of
go.
did you know?
One of the things is that you had mentioned about the hardware is OpenShift only cloud managed solution, or can you put it on-prem in your own hardware?
The question is, can we put OpenShift on-prem? Yes, and that's what we are doing with NOAA.
Is the ACM portion, is that cloud only?
The question is ACM live in the cloud or does ACM live on-prem? It lives in both. It can do both. Yep. Question here?
So when you're making the migration, it's VMs in both cases from your Red Hat virtualization into the OpenShift virtualization. What's the downtime though for the application to make that move? Is there any?
Well, unfortunately, because of hardware constraints, they're not giving us new hardware to do a side-by-side deployment, which does often happen. But in this case, we don't have that luxury. So we're going to have to back up all critical data somewhere, completely wipe out the current infrastructure, build OCP on top of it, and then we'll reinstall the software and re-import that data. So we don't know yet exactly what the downtime is because it depends on a lot of how long it's going to take for us to, I mean, the backup is fine, but how long is it going to take us to restore from wherever we end up figuring that out. There are, my understanding is there are tools that will take the images from RAI and export them somewhere, or I think it is a point-to-point, if I remember right.
Yeah, the question is, can you live migrate a virtual machine from here to there? OpenShift and OpenShift Virtualization does provide a migration toolkit. It will do a cold migration where the virtual machine, whether it's in VMware or maybe it's in something else, and it will shut it down and it will move it over. And it also has the idea of a warm migration. So a warm migration is where the VM is running, let's say in vSphere, for the sake of argument. It will snapshot that virtual machine and transfer as much data as it can. And then once it's transferred the bulk of it, then it shuts it down and moves it over, so the downtime is very minimal. But as far as like live, there does need to be a shutdown and a restart. Yeah. Question in the back?
Okay.
Yeah, what's the database, and is there requirements for HA for the database?
Are you talking about some kind of OpenShift component, or are you talking about a weather component?
Third-party component for, is it Postgres, is it SQL?
For our application, for our software running on OpenShift soon, it is Postgres. It's just an open source database that will compile and will put our data in. But as far as OpenShift itself,
Oh, I'm just queuing up the next question.
oh yeah, I mean, so
How do you handle high availability for that database?
we rely on OpenShift to keep the VM up. So, you know, he talked about migration, like live migration. You can do that internally as well. So OpenShift is handling the compute resources and storage over across 3 nodes. In this setup, one node can go down. So we were talking about patching before. Theoretically, when you patch, you're going to bring down one node, patch it, reboot it, comes up, wait till it becomes part of the cluster again, and then it moves on to the next node. So what it does is, and this is what would happen even if we didn't have VMs running on it, because there's pods running on node 1, right? So I forget the technology, I forget the nomenclature, but it like empties, I forget the wording, but it'll drain. It'll drain that node, you know, and it'll take all the, you know, reschedule all those pods and everything. Everything will move over to node 1 or node 2 and node 3. And once we put the VMs on there, they're treated just like a pod, so it's going to migrate all those virtual machines to the other nodes as well. So that doesn't change for us in the old environment or in OpenShift, in that we can survive having a node go down. You know, if a node were to be completely unplugged, you'll lose a little bit of time, because in that case it can't do that live migration, and it will just restart. It knows it's a highly available VM, and it'll start it on one of the other nodes. So. All right, I think that's all we got. If anybody has any questions, we'll hang around in the back for a couple more minutes. Thank you very much, guys.
Thank you.
Good questions.